Hello, Math 130 students. We are going to pick up on page 9, section 6.4 and 6.5, operations with radical expressions. So we want to make sure that we know how to simplify expressions involving these roots or these radicals. So remember, when we used to add or combine like terms, we would group together things that were similar. So here the 5x squared and the 3x squared are similar because they both have an x squared term. And now I have a negative 7x and a positive 1x. We know that by default the number in front of x happens to be 1. So I'm going to rewrite this as a negative 7x plus a 1x. So now I know that I have an 8x squared, and negative 7 plus 1 would give me a negative 6x. So hopefully that is a little friendly reminder of how we combine like terms. Well, I can do the exact same thing now with radicals. Well, I have 7 and 10. So I have 7 plus 10 that are like terms. And now I have this 5 square root 3 and this negative 1 square root 3. So that coefficient in front of the radical defaults to also be a 1. So now I have a positive 5 square root 3 and a negative 1 square root 3. So I have a 17. And now I look at my coefficients. 5 minus 1 would give me a positive 4 square root 3. And that will be my final answer. Now, looking at number 3, I definitely have a 1 square root 3m plus 9 square root 4n. But what we can do here is we can actually simplify this, because I know that my index is 2, and I know that 4 can be written as 2 times 2. So this first radical, 1 square root 3m plus 9 square root, and now I'm going to rewrite this as 2 squared times my n. So I know that this 2 is going to get multiplied on the outside. So when it jumps outside, remember your index, when it doesn't have anything inside the radical, it defaults to be a 2 since it's a square root. So this 2 kind of cancels out this exponent of 2. So I have 2 to the 1 power, and I still have my square root n. So now I have 1 square root 3m plus 18 square root n as my final answer. And notice how inside the square roots, so since this is a 3m and that's an n, those are different, so we cannot combine them any further. So that is as far as I can go. Alright, now looking at number 4, I'm looking at this and I'm like, okay, well, let's think about our index. Here my index is 6 and here my index is 3. So you have different index. And also inside the radical, the radicand is also different. And it's already simplified. So really, there's nothing you can do. This is already as simplified as possible. So your final answer is 8 6 root of 5x minus 3 third root of 3y. And that's it. That's as far as you can go. So here you just had to be aware that the index was different, the radicand is different. It's already simplified. You can't do anything with this problem. Now let's take a look at number 5. Looking at number 5, it looks like I can simplify inside the radical. So if I'm looking at 98, let's do my factor tree. So 98 is an even number, so I know for a fact that it can be divided by 2. So 2 times 49. Well, 49 can be 7 times 7. So now I have this 1/2, and I have my square root, and it's going to be multiplied by 2 times my 7 squared. Now I'm going to look at this 72. 72 can be split up. I know that 9 goes into it, 9 times 8, and 9 is 3 times 3, and 8 is 4 times 2, and 4 is 2 times 2. So I can think of this as a 3 squared times a 2 squared times 2. So I have a minus 6 square root of 3 squared times 2 squared times 2. And don't forget that your index is 2. So now I know that this 7 can come out, and since the index can divide my exponent, it cancels out. So I have my 1/2 that's being multiplied by 7, and I have my square root of 2 minus 6. And here it looks like the 3 can come out as well as the 2, because the exponent and the index, when they get divided, they cancel out. So I'm going to have this times 3 times 2, and what's left inside the square root is a 2. So now combining like terms, 1/2 times 7 is just really 7/2, square root 2 minus, and I have my 6 times 3 times 2. That's going to give me 36 square root 2. So now that I can see this, well, I know that I have a square root 2 and I have a square root 2. So those are like terms. So what I have to do to this side is I have to add or subtract these coefficients. So I have a 7/2 minus a 36, and I can say over 1. So I can either put this into my calculator or find my LCD, but 7/2 minus 36 gives me a negative 65 over 2. So now I know that my answer is going to be a negative 65 over 2 square root 2. I also could have written this as negative 65 square root 2 all over 2. So both of these represent the exact same answer. It's just whether or not you want the fraction out in front, or if you want the fraction to include everything. Okay. So notice how I'm doing my scratch work kind of in the same area, but just over to the side. So then that way I can refer back to it when I need to. Now we're going to switch gears a little bit, and now we're going to do this multiplication. So please remember that when we multiply, we are going to multiply the coefficients together. So here I have a 1 and a 1. So when I take this 2x, it's going to get multiplied by the coefficient. So I have 2x square root 8x minus 2x square root 50. But now I have to simplify a bit more. Let's look at 8. Well, 8 is 4 times 2, which is 2 times 2. So 8 is 2 squared times 2. So I have my 2x square root, and I have my 2 squared times my 2x. And I have minus my 2x. Now let's take a look at 50. Well, if I'm looking at 50, I know that can be 10 times my 5, and I have 2 times my 5. So this is 2 times 5 squared. So I'm going to be thinking about that square root of 50 as 5 squared times my 2. So when I simplify this, I have a 2x I have my index of 2, so I know that gets multiplied as a 2, and I still have on the inside 2x. And I have 2x, and here the 5 gets to jump out because the index is being divided by that power, and what's left inside is that 2. So now I have a 4x square root 2x minus 10x square root 2. And so that ends up becoming my final answer. And I can't do more with it because the radicand, the stuff inside the radical, are different. So that's as far as I can go. Now, for number 2, I'm going to multiply the numerator, or the coefficient times the coefficient. So that would be 5 times negative 1. Now, what I'm left with is inside the radical. Well, inside the radical, I have a 6 times my 12. So I have a negative 5. And if I'm thinking about 6 times 12, well, I know it can be split up. I know I have 2 times 3, and I have 2 times 6, and the 6 is 2 times 3. So it's really 2 squared, oops, not 2 squared. I have 1, 2, 3 2's, and I have 1, 2, 2 3's. So I have a 2 squared, and I have a 3 squared, and I also have that additional 2. So now that I know that this 2 can jump out, and this 3 can jump out as well. So I have a negative 5 times 2 times 3 square root of 2. So I have negative 5 times 2 times 3 is going to give me a negative 30, and I have my square root of 2. And that ends up becoming my final answer. So you always try to simplify if possible. Now let's look at number 3. If I'm looking at number 3, I am going to multiply the coefficients together. So 4 times 3 is going to give me a negative 12. And now I have the inside of the square roots that I'm going to multiply. So I have 2 times 32, which is 64. And I have k. If I have k to the 5th times k to the 6th, I'm going to add those together to give me a k to the 11th. And don't forget, by default, it is a square root. Well, I know that if I look at that number 64, that can be 8 times 8. So that's 8 squared. Now, if I'm looking at k to the 11th, then I can split it up. I can say it's k10 and k1. So now I have negative 12 square root of 8 squared, and I have my k to the 10, and I have my k to the 1. So all I did was rewrite it. So I know that this 8 is going to jump out. So now I have negative 12 times my 8, and I have this k, and don't forget 10 gets divided by the index. So 10 divided by 2 is a 5. And I still have k to the 1 on the inside. So now I multiply negative 12 times 8 gives me a negative 96. And you have your k to the 5th. Now on the inside you have k. So that ends up becoming my final answer. Number 4 is very, very similar. I have my index of 4, so that's great. So I have a negative 3 when I multiply my coefficients together. And now, underneath the radical, don't forget that index is 4, that's really important. So now when I multiply, I have 6 times 8, which is my 48. And I have b, and 3 plus 3 is 6. So now I'm going to try to see if I can break this up at all. So if I have 48, well, I know that's an even number, so I know that 2 can be divided. 24 is still even, so I know that can be divided by 2 again. 12 is even, so that's 2 times 6, and 6 is 2 times 3. So let's see what I have here. I have 1, 2, 3, 4. So 2 to the 4 times 3. So I'm going to rewrite this. So I have negative 3. I have my fourth index, and I have 2 to the 4th times 3. Now, if I'm looking at b to the 6th, I want to rewrite it so it can be divided by that 4. So if I make my exponents as, let's say, 4, then I would need 2 more to get to 6. So I have a b to the 4th, and I have a b squared. So now I know exactly what's able to jump out. So I have a negative 3, and I have my 2, and remember this exponent of 4 gets divided by the index, so it cancels out. Same thing with my b. And what's left inside, I still have the fourth index, and I have a 3b squared. So my final answer is a negative 6b, fourth root, 3b squared. And so that ends up becoming my final answer. So I'm going to go ahead and box this. And notice how for number 3 and for number 4, we started with an even index and we ended up with an odd power. So we are just going to assume that all variables are greater than 0. So whenever you see this statement, and in particular in your homework when you see this, then you don't have to worry about the absolute value. If I didn't have that statement where we assume all the variables are greater than 0, then I would need the absolute value. But in this section in particular, it's going to be all about assuming that all variables are greater than 0. So you don't need that absolute value. Now here, we can multiply 2 ways. We can either do the FOIL method or we can do the box method. But I do believe that students are going to appreciate the box method a little bit more. So just so you're able to see it. So I have a 4. And I have a negative 7 square root 7. I also have a 2 and a negative 4 square root 7. So let's see if this helps you guys out. So I know that 4 times 2 is 8. That's perfect. The coefficient times coefficient would give me a negative 14 square root 7. Here I have coefficient times coefficient, so it's a negative 16 square root 7. And 7 times 4, or negative 7 times a negative 4, is a positive 28. And this is kind of cool. I have square root 7 times the square root of 7. Well, that gives me the square root of 7 squared, which is just 7. So I'm going to have my 28 times my 7. So really what I end up getting is 8. And I can add along my diagonal here. So if I'm adding along my diagonal, I have a negative 16 minus 14, and that's going to give me a negative 30 square root 7. And if I have 28 times 7, that gives me 196. But now I can add. I know that 8 plus 196 is 204. So I have 204 minus 30 square root 7 as my final answer. And here I just like the box method because it just gets a little crazy doing the FOIL method when I have a binomial times a binomial. If you want to do the FOIL method, then that is fine. So remember the FOIL method, if you wanted to do that, you would have your first, your outer, your inner, and your last, okay? Now, for number 6, I'm looking at this and I'm like, okay, well, I'm going to multiply here, so I'd have a 5 third root 6 plus, and since these are both third roots, or the index of 3, now I multiply my 6 times my 12. But let's think about this for a minute. If I have 6 times 12, that can be reduced. I have 2 times 3, 6 times 2, 2 times 3. So I have 1, 2, 3 2's, and I have 2 3's. So now I'm going to say this is 5, third root of 6, plus the third root of 2 to the third power, times, and here that 3 squared is too small, so 3 squared is just the same as 9. So now I have a 5, third root of 6, plus this 2 gets to jump out, and I have a third root of 9. So my final answer, 5, third root of 6, plus 2, third root 9. And that is as far as I can go. And you know what? Just to be on the safe side, I want to make that 3 a little bit nicer. Okay. So for number 7, again, I really do enjoy using the box method on these type of problems. So if you want to do the FOIL method, that's fine. I just prefer the box method. So I have a 2. I have a positive square root 11. I have a 4. And I have a negative 8 square root 11. So now, using my box method, I have an 8, I have a 4 square root 11, a negative 16 square root 11, and a negative 8. And remember, if I have square root 11 times the square root of 11, that's the same as the square root of 11 squared, which is just 11. So negative 8 times my 11. So I'm going to have 8. And again, I can work across my diagonal. So I'm going to have a negative 16 plus 4, which is a negative 12 square root 11. And here, negative 8 times 11 gives me a negative 88. So combining like terms, 8 minus 88 is going to give me a negative 80. And I have my negative 12 square root 11 as my final answer. And so that is going to be it for this section. If you guys have any questions, please feel free to email me, the Math Success Center, or our embedded tutor. Thank you.